All right, so now we're going to do our second video over inverse function, or derivatives, derivatives. We'll do our second video on some of our derivative rules. So one of the later derivative rules that we did natural log, which I did a little bit in the last video, but natural log, all right, natural log. If you take the derivative, let's say I have ln the quantity 3x squared plus x, and I want to take the derivative of that function. All right, the derivative of natural log is the derivative of the function, so that's going to be 6x plus 1 divided by the function. So that's how you take the derivative of natural log. All right, so that's one that we should know how to do. All right, another one we should know how to do is take in the derivative of anything e to the x. So let's say I had an expression 2e to the 4x squared plus 1. And I want to take the derivative of that function. So that's derivative, anything with e. All right, his derivative, we want to copy what we see. Remember, his derivative is copy everything over. So 2e to the 4x squared plus 1. And then you have to multiply, we're going to multiply by the chain rule, which would be the derivative of the exponent. So then we take the derivative of his exponent, which is 8x. So really this would be 16x, if you wanted to simplify it, 16x e to the 4x squared plus 1. So natural log and e, not that hard. E is his own little family. He's pretty easy. All right. So always chain on the derivative of his exponent. Okay, now the third one I want to do in this video is doing the other bases, like a to the x. So let's say I had a function y equals 5 to the x, all right, and I want to find his derivative. All right, to find his derivative, you copy over what you see, 5 to the x. Remember, you have to change, let's make this x squared, just to make this a better problem. So we copy over what we see, 5 to the x squared. Then you want to chain on your derivative of your exponent, just like we did with e, so that would be 2x. But then because the base is not e, if you remember, we have to multiply by the natural log of the base. So you have to multiply by the natural log of 5. All right, so if I had another one, let's say I had 8 times 3 to the 4x minus 7. All right, that's what I got. All right, so my derivative would be, this is not a product because 8 is just a coefficient. So we would just copy what we see, 8, 3 to the 4x minus 7. Then I would chain on the derivative of my exponent, which is 4. And then I'd have to chain on the natural log of the base, which is 3. So then if I wanted to simplify this, I could make it 32 times 3 to the 4x minus 7 times the natural log of 3. All right? So that is your natural log. And now the other one I want to do is just refresh our memory over the inverse trig functions, not inverse functions, but inverse trig functions. And that I have a separate PowerPoint I want us to do. And we're just going to hit that very lightly. We're not going to hit it real strong. But we briefly went over it last year, so we need to briefly go over that again too. So just make sure you remember how to find derivatives of everything we learned how to do last year. And then there's one more video here. All right.